Most AI agents have amnesia. Not the kind where they forget your name, the kind where they make the same mistake 3 conversations in a row, and there is nothing you can do about it because the memory system either doesn't exist, lives on someone else's server, or costs you per query. ClawMem is a direct attack on that problem. It is an open-source agent memory layer that runs entirely on your local GPU, claims state-of-the-art retrieval performance, and stores nothing in the cloud. Let's look at what it actually does before we talk about what it can't. At its core, ClawMem gives your AI agent a persistent, searchable memory. When your agent finishes a task or a conversation, ClawMem encodes that interaction into a vector embedding and stores it locally. The next time the agent needs context, say, a user asks something that was already answered 2 sessions ago, ClawMem runs a similarity search directly on the GPU, not on a remote API, and returns the most relevant memories ranked by semantic closeness. That's the retrieval step, and that's where most memory systems fall apart. ClawMem's claim is that its retrieval is SOTA state-of-the-art for local, GPU-accelerated setups. And from what I've tested, the speed is genuinely impressive. We're talking sub-100 millisecond retrieval on a mid-range consumer GPU, for memory stores in the thousands of entries range. The practical workflow looks like this. You wrap your agent loop with ClawMem's memory interface. After each interaction, you call a write method. Before each new response, you call a query method. ClawMem handles the embedding, the indexing, and the ranked retrieval. The integration is intentionally lightweight, a few lines of Python. No running a separate vector database server, no configuring Pinecone, no API keys. Everything lives on disk and in GPU memory. But here's the thing, and this is where I want to be honest with you, ClawMem is a very young project. There are real gaps. First, it does not handle multi-agent memory sharing. If you're building a system where multiple agents need to access the same memory pool, ClawMem doesn't have a native solution for that right now. You'd need to architect that yourself. Second, there is no built-in memory decay or forgetting mechanism. In human memory, irrelevant things fade. In ClawMem, everything you write stays with equal weight forever, which means over time, retrieval quality can degrade as the memory store grows with noise. Third, the SOTA claim needs a caveat. It's state-of-the-art for local, GPU-bound retrieval, not compared to cloud-hosted systems like Pinecone or Weaviate with dedicated infrastructure. Those still win on scale. If you're dealing with millions of memory entries, ClawMem is not your tool yet. And fourth, documentation is sparse. This is a community project. The GitHub has the core functionality, but if you hit an edge case, you're reading the source. What surprised me was the embedding model flexibility. ClawMem doesn't force you into one embedding model. You can plug in whatever sentence transformer or custom model your project already uses. That's actually a big deal for teams with domain-specific embeddings they've already trained. So where does this realistically go from here? A few things seem genuinely plausible. The most obvious next step is a memory compression layer, something that periodically summarizes old memories into denser representations, keeping the store lean. That would fix the noise accumulation problem and make long-running agents actually viable. Another plausible evolution is tiered memory, hot memories on GPU for fast access, cold memories on disk with slower retrieval, mimicking how human short-term and long-term memory actually function. And if the project gains enough contributors, a multi-agent memory sync protocol becomes achievable. That would unlock a whole category of collaborative agent architectures that currently don't have a good local solution. Now, why does this exist at all? Because the repeated mistakes problem in AI agents is not a model problem. It's an infrastructure problem. GPT-4 doesn't remember your last conversation not because it's dumb, it's because the systems wrapping it don't give it persistent context. The workarounds people use, stuffing entire chat histories into the context window, paying for managed vector stores, building custom retrieval pipelines from scratch, are either expensive, brittle, or both. ClawMem exists because a developer got frustrated with all of that and decided the primitives should be open, local, and fast. Whether it becomes the standard solution or just a useful reference implementation, it's already doing something valuable, showing that SOTA retrieval doesn't have to live in the cloud. If you're building agents and you haven't thought seriously about memory architecture yet, That's probably the gap in your stack right now. Next episode, we're looking at a tool that tackles the other side of agent reliability, the decision-making loop. Subscribe so you don't miss it.